So yeah, just go to the next one right now. Yeah, and then next one. Alrighty. Welcome guys to our first general of Midnight Sun. My name's Yenshen. I'm the project manager for the team. I'm in my 2B mech term right now. And yeah, next slide. So yeah, just the agenda for today. I'll just give you guys a brief intro to the team. Then we'll go into sub-team overview with all the sub-team leads kind of giving a brief description of what their sub-team entails. And then we'll wrap it up with some next steps and how to get you started. All right, so what is Midnight Sun? It should be obvious, but for those of you who still don't know, we're the University Solar Car team. We were founded in 1988, which makes us the oldest team at the University of Waterloo. We compose of 75 members, divided into 5 sub-teams, and yeah, we aim to build solar cars from scratch, full-size solar cars. Next slide. Yeah, and so our goal is to ultimately build a solar car to compete in the American Solar Challenge. The next one that we're planning on competing in is the 2024 one, which happens in July. And as you can see on the map, it kind of spans, like it goes across America, spanning over 1,000 miles. And that's an example of the route of the 2021 American Solar Challenge. And below, you can see some photos of past solar car vehicles that are single occupant, which is the vehicle class that we are competing in. It means there's only going to be a driver in there and no other passengers. And as well, a very simplified timeline and where we're currently at. So the last 4 months, at the beginning of this year, actually, we just started our new design cycle. And so now most sub-teams are done their research phase and they're heading into their early design phase of the cycle. And so, yeah, we're still, it's a 2-year cycle and we're like 4 months in. So there's plenty of work to go. Next slide. Yeah, so what we're looking for a commitment, an open mind, and just being collaborative. I'm pretty sure all the other sub teams are going to tell you the same, or all the other design teams will tell you the same thing. We just want good people who will join us and help us build this car. Yeah, and why join Midnight Sun? So, Jen, yeah, you want to take it away?
I don't know if the mic is working, but hi, my name is Jian, and I'm the operation manager of the team and the business lead. Why join Midnight Sun? So there's 3 reasons why we think you should join Midnight Sun. First is the learning experience. So we do things that professors doesn't teach in class. So you can get practical experiences, learning experiences, and also hands-on experiences. So we would ask you, we'll give you a task and you will work on them. And that's why we highly encourage you to join because you get experience out of it. And also we are working on a very unique project, a solar car. So I think it is a great opportunity for you guys to just work on something that actually exists in real life, a physical car. And it is a cool project. We do start from scratch, as Yansha mentioned, and we are currently in our design phase. And our community is very welcoming. As you can see, that is our dynamics lead, Jens, over there. Yeah, so we would do socials a bit, and we also highly recommend you guys to just reach out to us, talk with us, chat. We would love to have a chat before Midnight Sun or any other interests that you guys are just currently into, etc. And yeah. So yeah, some classic questions that we get is, do I need to apply to Midnight Sun? No, if you are here, you're already in. So we're all good to go. Just check Slack. We will send a couple messages there. Just so keep an eye out on it. We have onboarding sessions. We have one-on-one sessions coming out. The leads would message you if there's any other tasks that we want you to work on. So yeah, keep an eye out on our Slack. That's our communication channel. And second question, can I join if I'm not experienced? Yes. We believe that if you're willing to learn, you're qualified for this team. We highly are looking for people who is willing to learn and just gain new experiences and wanting to put some effort into the team. So yes, if you are not experienced with it, do not worry about it. We'll teach you from the scratch. Third one, how much commitment is expected? So that really depends on you. So we believe is what you put in is what you get out of it. Let's say if you want to join multiple sub teams, you will probably have a lot more workloads than other members who's only in one sub team. So that's kind of like, it's what you want. If you want to get a lot out of from this, let's say if you are interested in business and mechanical or business and farmer, definitely your workload would be a lot higher or a lot more than compared to the person who is just in one of the sub teams. But yeah, that is really up to you. And last question, I think Yenshin will explain that a bit.
Yeah. So how will the spring? How will this term look like? And the short answer is it's going to be a hybrid model. And that depends on which sub team you're on. I know just the fact that most of our leads are in person this term, but just based on the nature of the sub team, like mech and hardware, they might have more on-site sessions versus business might work more remotely. It's all dependent on your sub team lead, and so but just expect that you will have the check-ins that will have Zoom links available for those who can attend in person. However, depending on the team, there might be in-person working sessions and just get-togethers that will be on site. Yeah, and I can just, like I said, there are 5 sub-teams. Here they are. There's business, mechanical, firmware, hardware, and strategy. I could give a description of each one of them, but they're all here anyway, so they can probably give a better one than I can. So, yeah, without further ado, I think hardware is up. So, yeah, Ricky, Tanish, you guys want to take it away?
Hi, I'm Ricky. I'm one of the co-leads for the electrical team. And here with me is Tanish. He is one of the leads for the electrical team. So for hardware, what we mainly do is design the electrical systems for the car. So we try to make sure that everything is, we try to get like the power for the car to be able to run. So for the for our electrical system, we have 2 systems for it: the high voltage systems, HV systems, and low voltage systems, the OV systems over there. So for the high voltage systems, we have components such as batteries, motors, and solar panels. These are what takes up most of the power that the car uses. While for the low voltage systems, we have driver controls, battery management, telemetry, and power distributions. These are like more smaller modules for the car that just like make sure that everything is going okay, but they don't really use as much power as like the main components of the car that makes it move. Next slide. Yeah, so for the team, as I said earlier, over here is Tanish, is one of our team leads. We also have another team lead called Alistair. Unfortunately, right now he is on co-op, so you might see him online and on Slack, but in person, I'm not sure if he's going to come. And for the co-leads, we have Lucy, Kevin, me, Ricky, and Odie. So I believe Kevin and I should be in person this term, and Lucy and Odie, you'll see online. And we also have 5 advisors who are our previous leads, but they're in their 1st year, so they don't have enough time to commit everything because of capstone. So they're advisors now. So the 5 are Ashmika, James, Liam, Micah, and Nita. All 5 of them are very knowledgeable. They've been helping us a lot, and they're really nice to talk to as well if you need any help with anything with the team. Next slide. So for sub-projects, so our car is, so for the electrical system, there are 6 components to it. We have the powertrain, which includes motor interface, pre-charge, DC-DC converter. We have the batteries, BMS battery management system, solar, which has solar sense, and the array layout. We have driver interface, which has driver controls, displays, and lights. Telemetry, which includes sensors, Wi-Fi LTE, which is just how we can connect to give data from the car to our strategy team. And we also have the infrastructure, which is controller board, power distribution, which just helps just kind of routes where like the power goes from which part to which part of the car. So in the side over here is just a diagram of, it's kind of like a high-level diagram of one of our parts of the car, which is the the battery or the battery management system. So as you can see, we have the BMS carrier, 3 AFEs, and a current sense board, and a few relays, fuses, and a few other things. All 6 of these subcomponents all connect together with the car, obviously. Next slide. So what do we mainly do in the electrical team? So we do a lot of schematic capture, PCB, and physical board, which is we do a lot of, we have to create the schematics for each board, which is just like wiring up all the circuits. And then for the PCB layouts, we just, you have to place all the components to the board, as you can see in the middle image. So what we have to do is just make sure everything is, all the parts that we're using can be put on the board and is connected together. And then after that, we just send the board out and get it back together, assemble it, and then that's how we get the physical board on the bottom left. Next slide. So after that, this is a much later stage. We will have something called board bring up, which was, as I said earlier, about the physical board, which is we kind of assemble all of the boards together. And for the very end stage for electrical is wiring and harnessing, which is just wiring up all the cars so all the electrical components can be together and just connecting everything together. So what you can get out of this, of the team, is that you get a lot of soldering experience, because we will be able to let you assemble all the boards, do all the solderings and stuff. You will get board testing and validation skills, which is pretty good for getting QA jobs, and also being able to have hands-on experience with all these boards. And you'll also be able to help out with all the layout of the electrical system. So you can help out with planning where you want each part component of every component in the car. Next slide. And that is it for hardware.
Nice. Good job, Vicky. All right, so I'm hoping this mic can pick us up. But we are the firmware team. We're in charge of doing all the programming for the car. So we write really low-level software in C for these controller boards and to run all the stuff in the electrical system. So like you just saw from hardware, we've got this big, complex electrical system, controls all the different parts of the car, and we are the ones that do all the software to, they build all the boards and stuff, and then we write the software to control it. So I don't know if anyone's ever worked with Arduino, like this lovely one right here. It's very similar. You're interacting directly with sensors, outputs, and things like that. But we've used S2022s. It's a little bit more advanced and better for our purposes. But yeah, what you can learn things like industry-level embedded software. We're working on real-time operating systems this year, so it's another buzzword you can pick up on. And how to be a member of a software organization. So we try to run a very mean, clean software organization, and there's lots of tooling skills and things like that you can pick up if you join. Yeah, you go to the next slide. So it's myself and Jarvis are the team leads this term, and we'll talk a little bit more about kind of what we do. So at the top, those are our controller boards. That's what we stick on the electrical components to do all the control. They're also in the electrical designs as well. And then this is what our mock-up looks like. So when we start to put the systems together, we get this big jumbo spaghetti that is our car electrical system laid out. But we work on things like battery management, power output, anything that is doing anything in the car that's electrical is controlled by firmware. And so for this term, we're at the start of a design cycle. So it's a really exciting time to join for either us or hardware, because we're ready to start. We're going to be carrying everything through from research to design to getting the boards manufactured to putting the firmware on them and all the way through to production. So you get this great experience of this whole continuous process. And so this term it's going to be, we're working on upgrading our libraries. So for those people who know what FreeRTOS is, we're migrating our previous firmware to be FreeRTOS compatible, to make it more efficient. there's going to be some high-level design on some of the systems that we're building, and some other tasks related to our software. That's pretty much it for us.
Hi, everybody. Can you hear me from here? I know we don't have a mic working. Yeah? Okay, good. So hi, everybody. I'm Emma. I'm one of the co-leads for strategy this semester, and this is Rodrigo, who's the other co-lead this semester. And we're here to talk to you about strategy. So the first thing I'll talk about real briefly is about what strategy actually does. And so the purpose of strategy is to really understand how the car works and how we can race the best that we want to race. So I think the other teams have talked a little bit about how the car itself is made, about like what goes into making the car hardware, about what goes into making the car firmware. But once the car's assembled, we want to be able to race really effectively when we get to the race site. So that means that we want to understand things about the car environment, so like the weather, things about the car itself, so how its systems interact with each other, get information from the car system, so through things like CAN, and then use all that information to kind of predict how it's going to go, and then make it work even better and score more points, and then ultimately do better in race. So yeah, that's the goal overall of the team, and like all the other teams on Midnight Sun, we're in initial phases of this car. So we're in the middle of sort of transitioning from a lot of MS-14 material into MS-15, and kind of understanding what it means to be a single occupant car, and then using a lot of the code and what we've learned previously to kind of apply it to this current iteration.
For sure. So as Emma mentioned, we're very early in our development. We're still sort of ideating what we want to do for the term. So it's a great sort of opportunity to join the team and get started while we're still developing our code. And of course, we're open to many ways to optimize how our car performs and maximize our score. For the 2024 competition, we're operating with an SOV vehicle. So our score is very much based on the distance we travel. So that being said, in order to win the race, we want to have the majority of distance throughout the duration of the race. So we're looking at stuff like optimization of the route model. So we're using, I think right now, previous routes books to just look at the data they provide us on the route and take in weather data through APIs or other real-time data from other systems in the car to really optimize the routes, the speeds, and our performance throughout the race. Another example of a project we're working on is a loops. So for the loops, of course, the race is all about maximizing our distance. So the organizers of the race have added some optional loops throughout the race, and these are basically just circular routes around the main route. And basically what we're working on is finding out, okay, can we assign a cost-benefit ratio to the loops beforehand, before we actually race, to give our driver an indication of, okay, this loop is actually, it's going to cost us a lot of power, but it's going to give us a lot of distance. So it's sort of like an efficiency metric before the race to gauge how each loop will benefit us even before the race starts. And of course, during the race, we'll be using real-time data through our models to say, given our current state of charge or given our current even time, duration, the weather, all these kind of considerations and data, is it affordable to go through this loop? And if so, what sort of speed, what sort of handling of our performance can we do to make sure it's as efficient as possible?
So yeah, a couple of logistical details. I know some of the teams have talked about whether they'll be in person or not. Our team does operate completely remotely. So you see us here today, but all our meetings will be over Meet. And so if you want to join a team, we'll be sending links in the Gen Strategy channel, so feel free to join the Slack or message me, and I'm happy to send the link there. Currently, the time that we have for our meetings is Saturday at 2:30 p.m. Eastern Time, so we hope you can make it. And otherwise, I don't think we have any plans to change that, but if someone really needs to change that, we can always update asynchronously. For technical details, if you've touched a lot of code before, you might be familiar with some of these technologies. We use a lot of Python when we do our coding, so almost entirely Python in all our code bases. And you'll see us interact through GitHub. So because we operate completely remotely and because we deal with code, we wanted something that allows us to version control all that we do without having to actually interact with person, having to deal with conflicts and all that. So GitHub is really the perfect tool. If you've used it before, great, that would be super helpful. If you haven't, no worries, we're happy to teach all of that. I actually learned GitHub through this team, so it's pretty easy to pick up. Otherwise, if you want to see our code or you want to see some of the previous work that we've done, it is available at these two links. I think the slides are going to be sent out after.
Yeah, that's correct.
Okay,
Slides
so
will be sent out.
those can be clicked on when you get the slides. And the last thing that I touch on here is Confluence and Jira. So we are a team, so we have a lot of documentations or project management. And so you'll see us use this just to keep track of sort of historical details and a lot of information going forward. I think that's all I have to cover. The only other thing that I guess we normally mention is our program. So yeah, hi, I'm Emma. I'm a 3A Systems Design Engineering student, and this is Rodrigo.
And I'm Rodrigo. I'm 2B Management Engineering.
Yeah, so that's it we have for today, and hope to see you soon.
All right. So hey, I'm Gian again. I'm the business lead. I guess I should say my program. I just finished 3B of GBDA. For those of you who do not know what that is, it's Global Business and Digital Arts. My campus is Astrover, so you might not know the program. But yeah, business is all about making sure that our team runs. So we deal a lot of logistical, finance stuff, marketing, and sponsorship. We have 4 sub-teams. We have marketing, finance, sponsorship, and SI, and our team leads are all up there: Ashley, Amanda, Kelly, and Kate, and Lily. Lily, if you want to just stand up and say hi. The other leads are sadly not here because they're either on co-op or just busy and cannot make it to this meeting. But yes, I will be going over some short little details about what each sub-team of the business sub-team do. So first of all, marketing. They work on our branding. So what you can see on the social media, our Instagram, website, Facebook, LinkedIn, that's all what marketing does. They make social posts. They make sure that we do not go dark on social media and make sure that the world knows that we are Midnight Sun and what we do. Finance, we keep track of expenses, reimbursements, so all of those money, financial, internal book stuff. They are great at keeping track of them, making sure our transactions are straight and clear. Next slide, please. And also supplier interfacing and sponsorship. So for now, we are combining those two teams because they're very similar to each other. So both of them are sponsorship. It's labeled under sponsorship. The only difference is that supplier interfacing, we get in kind, meaning like services or materials from local companies as sponsorship. So we'll ask them to make a part for us, like a dynamic part, and then they will make it for us. And that actually counts towards sponsorship because they are we're not paying anything from them. We are going to advertise them in our race, and then they're sponsoring us. So that's how supplier interfacing works. And sponsorship is mostly internal endowment funds, but also external monetary funds as well. So we would ask local companies or big companies and apply to those applications or email, cold call, so we get our money so that we can make our solar car. And these are some of the previous past projects that we did. So we created something called brand book so that our social media is very coherent and consistent in terms of branding. So we're using the water fonts and also those colors you can see on the top. And then the task for sponsorship, we have done crowdfunding projects. So we would create those merches like you see in the photos. We're not currently thinking of doing it in this term just because we are pretty fresh new in this project cycle. But it could be a future project that we might do in marketing or crowdfunding. And also social posts is one of the big marketing projects that we do. So all the things you see on Instagram, social media posts, we have sponsor Sunday posts, we do holiday posts. In the past, we have done member spotlight. So we would interview one of our leads and then tell all about what they do in the team. So yeah, those are the past projects of businesses.
I think that's it. Yeah, last but not least, mechanical.
I can go for it. All right. So the mechanical team. I like to split this team into our A, B, C, and Ds of this team. The A being the aero body, the B being the battery box, C being chassis, and D being dynamics. Each team will go a little bit deeper as to what they do a little later on. But a little bit of an interview to mechanical. We are responsible for all the moving parts of this team. Some would say We are responsible for the car, but I think Mitchell would like to argue a bit.
You better believe it.
And a few of the names for the leads, and I'll get them to introduce themselves when their sections come up. And we can start off with chassis. I know it's not in order, but it's not the alphabetical order, but we'll continue as is. All right, so for the chassis, I myself am Mohammed, the current chassis lead for Midnight Sun. The goal for our current term is to design the structural frame that will be protecting our driver throughout the race in 2024. So some examples that we have on screen are the MS-14, the previous vehicle that we had. That was the chassis that we had. Some of you, if you've ever passed by the bay, that would have been the metal frame that you saw around. And some of the current renders that we have right now, some members have thrown a few chassis structures in, and this is what they've created. And so for this term, what we're aiming to achieve is design, optimize, and potentially start manufacturing the chassis in-house. And so some experience that you might be gaining is, for one, modeling the entire chassis and modeling that entire structure, coming in, joining, learning a bit of FEA. I know some terms will get thrown around throughout this meeting that might not be clear, such as FEA, CFD, RTOS, whatever the terminology might be. That's all right. Most of us didn't know these terms until we joined the team. And I believe most leads will be available after if you have any questions to ask as we go. And I'll pass it on to Michael for aero.
Yo, I'm Michael. I'm the aero body lead for this car, and I'm currently in my 2B of nanotech engineering. So yeah, what does aero do? We basically make things look nice. We don't like math. We just make things look nice in general. So basically, our process of design is research, design, manufacture. So for this term, we already have a general concept of what the car will look like, as you can see over here. So now it's all about optimizing to improve aerodynamic performance to the peak, to the best of its ability. Because within like solar cars, power in equals power out, so we don't want to deal with that much drag force since we don't have that much power. So that's why the coefficient of drag is very important. So basically, some good projects that you can work on this term, just in general, is full aero body design. So you'd be able to make that type of car by the end of the term, hopefully. And then you'd run CFD simulations, so that'd be a computational fluid dynamic simulation to assess the aerodynamic performance. And then in tandem, when we always designing, we want to do panel integration and mold design. Because yeah, this might look nice, but if we can't make it by ourselves, then there's no point. So it'll be a tandem of, can we design it? But once we design it, can we make the molds for it and see if we can do it in-house? So there'll be a nice back and forth between that this term. And if those that are making the molds can see that we can't make this in-house, then you tell the people that are designing, hey, let's not do this anymore. And then something very nice about Aero is that we have a composites manufacturing portion, which will be starting this term. So you guys will get to work with our Lord and Savior, carbon fiber, this term. So we're going to be making 2 test pieces. We'll be making the hood mold, the hood of a car, out of carbon fiber, and we'll start from ground up to full finished part. And if we have time, we'll end up making the front section of this car, again, from the ground up, full carbon fiber. So that's something that we can do in term during this term. So yeah, get a good, it's called a good balance between design and manufacturing with this team. So yeah, that's just a bit about Aero. Thanks.
Right. Hello. I'm Jens. I am the dynamics lead. A lot of you have probably seen me in class because I see half my cohort here. The people who know in my cohort know. Anyways, so dynamics, what we do, anything that moves relative to the car's chassis or deals with the car's motion, either going forward or back, we start taking a look at. So in really broad senses, we look at suspension, steering, and brakes. Suspension, both for front and rear. Steering, to make the car go the way we want it to go. And brakes, because stopping a car is not a bad idea. So right now, we're in a very early stage of our design, as every other sub-team is. And this means that we need to figure out a lot of placement for our wheels and how we want to design parts moving forward. So especially in dynamics, there's a lot of research because vehicle dynamics is an actual profession, and learning that all in your spare time is pretty fun if it's as broad as going through each subassembly. But what we've done is we're breaking it down into these 3 subassemblies, so the people who join dynamics can focus on one of these subassemblies and specialize their knowledge a little bit more, just so they don't go overwhelmed with all the information at once. It's tough, believe me. So, quick overview of suspension. There's some broad geometries that we look at. So there's MacPherson strut, double A arms, and trailing arm. There's also one that's very common with solar cars called leading arm. And leading arm's kind of tough, so we're not going to do it. Double A arm's probably the way we're going to go for our front suspension, and we're probably using a trailing arm for our rear. In steering, we're still in some concepting phases, so I don't have a picture of it right here, but there's a mechanism called a rack and pinion. So a quick way to describe it, imagine a small gear and then a comb with really short teeth. That's the rack. The small gear is the pinion, and that creates lateral movement. That lateral movement then translates into other linkages, which then get the right proportions for our wheels to turn based on the gear rotating, which is attached to the steering wheel. And in brakes, there's a lot of off-the-shelf part selection. So brake pads, calipers, master cylinders, hydraulic lines, because we're using hydraulic brakes. And we're just now verifying parts from our past car because spending money isn't that great on the team, even though we all like a little bit of retail therapy. Team stuff. But so we're validating components there, and then we'll move into some design into the mounts for the calipers. So the caliper has to actually be attached to the suspension system. It can't be on the chassis because if the wheel moves away from where the caliper is, then you can't actually stop the car. A little bit of a safety hazard. So there's a lot of design in brakes moving forward, but right now just off-the-shelf part validation. So yeah, I will be around afterwards if you want me to go in depth with any of these topics or subassemblies, because I know I give a very broad overview, but believe me, digging into each of these, I can take up a good amount of time. So yeah, thanks guys.
Hey everyone, I'm Eric. I'm in 2B Mechatronics, and I'm one of the co-leads for Battery Box. The other co-lead is Owen Lee. He's currently on his co-op team, co-op term, so we're opposite streams. So you'll probably see one of us in the bay every other term. So Battery Box, what do we do? It's kind of in the name. In the most basic of terms, we kind of just put batteries in really fancy boxes that we design. And then we build around 18 of these individual modules that we call here. And then we connect them all together into this pack you see at the bottom here. And then hopefully it's able to power the car for the entire journey of the race. And so into these modules, there's a lot that goes into the design to make sure that the batteries are providing power efficiently and we're not losing energy through heat. And if it does heat up, you got to make sure that there's no batteries going haywire and causing a chain reaction that ends up to the pack exploding or catching fire or anything like that. So that's basically what we do for Battery Box. And for this term, we mainly have 2 projects that we're working on. So first of all, we need to choose a battery that we're going to be using for our car. So there's mainly 2 types of batteries. There's a power batteries designed for more power, and there's batteries designed for more capacity. So power batteries would would run cooler underneath higher current load and things like that, while higher capacity batteries would have higher capacity, and we are able to store more energy and hopefully run further on those. So we have a shipment of some sample cells coming in, hopefully next week. And then we're going to be running some tests on the individual cells. As you see here, we have a testing setup, and then hopefully determine which battery cell we want to work with and buy a bulk purchase of around 400 batteries to put into our car. And so that's the first project. And secondly, we're continuing our design cycle, design sprint of the modules. As you see here in the middle here, those are 3 different renders. So the one on the left is the one that we had for our previous car, but we can't use that this year, unfortunately, because we have a single occupant vehicle. And in the middle here and the right here are some of our ongoing designs that we're hoping to complete in the next week or 2 and then start manufacturing. And so with these prototypes, we're probably going to be manufacturing them out of 3D printing and doing some spot welding, which is a different kind of welding from the normal soldering and things like that we have to use with these batteries. So we're going to be hopefully building them and then testing them if we have time this term, and then hopefully getting all our learnings together and finally designing one final module that we want to manufacture in bulk. So those are two of the projects that we're mainly going to be working on, and hopefully if you guys are interested, you guys can join in our meetings. I'm not sure if anyone mentioned, but our meetings are at 9 p.m. on Mondays, so they're held virtually, but I'll also probably be in the Bay, so if anyone's interested, feel free to drop by. And yeah, that's Battery Box, and I think that wraps it up for the mech team.
So yeah. So now you might have questions, well, which sub-team I should join? So we listed out for you. So if you're interested in mechanical design, battery development, manufacturing, design a little bit of like the mechanical part of the team, definitely join the mechanical team. If you're into programming and software development, join the firmware team, board and circuit design, hardware, graphic design, marketing, finance, communicating with people in general, business definitely, and also data science and statistics for strategy team. And yes, you can join more than one sub-team. Join how many you want to join. So yeah, some next steps and important information for you to know so that we can move forward after this first general. So yeah, we do have some onboarding one-on-one sessions mostly on Saturday. So mechanical will happen at 10 a.m. in E5 room 2004. And business will happen through Zoom. We'll send a link out in the Slack at 1 p.m. And also firmware will happen at 1:45 p.m. in E5 room 3052. For firmware, we're not going to send a Zoom, like a Teams like or Zoom link so that you can join live. So be aware of that. But for mechanical, we will be probably. And also for hardware, it will be to be announced. It will be most likely happen next week. And please join our communication channel today so that you can get all of the updates or notification of when those one-on-ones happen, when those team general meetings, sorry, not general, sub-team meetings happen. And also, yeah, check what we've done, what we worked on our Confluence, which will tell you how to join the next slide, few slides later. But yeah, as I mentioned, again, onboarding 101, if you want to take a photo of that, please do. We will send that information out on Slack again. And then how to join, we will be emailing you one more time after this first general about this information. If you signed up through that link, if you haven't, please do. That's our emailing list. So if you haven't, please sign up through that Google form, okay? And then, yes, the email will contain the room number. It's that Sub-Team 101 is happening in person. It would include Zoom or Teams link if it's happening remote. And then if you didn't register your email yet, please join on Slack because we will still send updates or notifications through Slack channels. Yeah, and then some team tools as I emphasized so many times. Slack is our main channel for communications. This link right here is our Slack channel, so please join today or as soon as possible. Confluence, it's home for all the project documentation we have, and then we have a Google Drive for Midnight Sun so that we can store all the documentation, notes, and media and various files that we need for each sub-team. Yeah, and then we listed out some important Slack channels for you, and I believe you already joined when you first log into the Slack. So we have the general for general announcement, meetings for meeting links and reminders for meetings, business for business team, mechanical for mechanical team, select hardware for a hardware team, select firmware for firmware team, and gen strategy for strategy team.
Alrighty, back to me. So for team meetings, in the past we did have general meetings every Wednesdays at 7, but long story short, no one showed up, so that got cut. Instead, we do have leads meetings that are still happening, but as a regular member, you are definitely not required to attend them. There will be meeting notes that I will be sending out into the general Slack channel. And that's for any regular members who are looking to become core, and so you will still know what's going on around the other sub-teams and be in touch that way. I guess the main note on the right here that I wrote out is reach out to your sub-team leads, just because those meetings will be the ones that you will need to attend as a regular member, and it just depends on your sub-team lead. and when they've scheduled their meeting. And also, if you want to join other meetings, or you just want to know what's going on around, we do have a Google Calendar. And so if you add our Google Calendar at the solar@uwmidsun.com, then you can get access to kind of all the meetings that are going on. I gotta admit, it doesn't get updated too often, but it will be updated at least for this term shortly. So add that if you do want to know when the other sub teams are meeting as well. Alrighty, and yeah, here are the meeting times for all the sub teams. I believe some of them might be a bit outdated, but it looks good for the most part. I think in order to actually determine if this is the right time, join the Slack and message your sub team lead. That is kind of the first step that you need to do if you want to get involved. Right, here's just some general advice. This was said before, but what you get out is what you put in. Right, take that with a grain of salt. We're all students here, and I hope none of us are skipping class to do team stuff. And yeah, so we're not doing that yet. So yeah, don't expect like you need to work a lot. But just yeah, when you do put in more time, you'd be surprised at the amount of experience you'd gain, and how much responsibility you gain as well. And yeah, the second point is ask questions and ask for help. I think all the sub-team leads can agree to this, that they need members that they can trust. And in order to trust them, they need to kind of have communication, be in touch with them, just kind of get to know who they are and be comfortable giving them important tasks. Because ultimately, our car won't get complete unless we have dedicated members who they can trust with delegating large tasks of the vehicle to. Yeah, and then the third one, just be an active member of the team. And this varies, right? During midterms and finals, everybody's busy, and so you shouldn't expect there to be working sessions throughout those times. However, being active would mean maybe just messaging, saying if there is a meeting during that time and you're a bit slogged, just reach out to your sub-team lead, shoot him a message or her a message saying you can't make it, just so they know where you are and they won't assume you kind of dropped off the team. Yeah. Next slide. Alrighty, and who to talk to. So, this is, most of us are here, but here are kind of the, the roster, the leadership roster for this term. For business, you can talk to John, firmware, Jarvis and Mitchell, hardware, Alistair, and or Tanish, mechanical, all these guys over here, and then yeah, strategy, Emma or Rodrigo. And yeah, just for miscellaneous stuff, if you don't know where you want to go, or if you're looking into some management or whatnot, you can message me. I'm always free to chat, and I'll also be down in the bay chilling most of the time. So if you want to stop by, I probably will be there. Yeah, next slide. Great, that wraps it up. Thanks everyone for coming out. This was a great turnout. Couldn't ask for much better. We basically filled up the room. So yeah, if you guys are interested or if you guys have any more questions, us leads will stick back for a couple minutes just so you guys can come up and ask any of your questions. But yeah, next steps, join our Slack channel, go on our website and go to uwmidsun.com/join us. That will give you guys access to our Slack channels, and that's where we'll literally be posting everything that's going on, and so you guys can get in the loop that way. But yeah, thanks for coming out, guys. Hope you guys have a great term, and yeah, hope to see you guys soon. Great. All right, we can cut that now.